All right, hello everyone. Today we are going to keep moving forward and we will be looking at section 5.4, function notation. And really we should call today 5.4a because we will be taking some time to look at section 5.4 today and tomorrow. If you'd like to follow along with me in the book, we'll be on page 224. I know you can't really see it. I don't know if I can move this arrow. Whoa, don't do that. But I can just switch the view. There we go. You can see we're on page 224, so you can get there if you would like. Kind of as a quick recap of everything that we've talked about so far. We have said and recognized that we have these things called a line that are on a graph. And more specifically, we have said that we call a line, a straight line like this, is a linear function, right? Linear kind of makes sense because it is in a line. And that linear function form is y equals mx plus b, where m is our slope and b is our y-intercept. And what we have said, if this function, let's say that it's y equals 2x plus 1. Okay, the y-intercept is pretty close, and that's a decent slope. So if that is our function, or a linear function right here, then what makes it a function is that for every input, for every x value, there's only one output, right? We can't put 2 in for x one time, and then we get 5, and then the next time we put 2 in, we get 12. That doesn't work. That would not be a function, and that would not happen when we have an equation written like this. So we've talked about how to find the slope of the line, that m value. We've talked about how to find the y value, but we haven't really talked about a whole lot past that. So today we are going to look at a little bit of vocabulary and just change and tweak one term, and then tomorrow we're going to dive into a couple of different types of linear graphs. So our learning targets, students will be able to evaluate, solve, and graph functions written in function notation. There's our key word. We will dive into what that means here in a second. Students will be able to compare graphs of linear functions. We're going to get into that today, but that's going to be more of tomorrow's learning target. So, function notation. By naming a function f, you can write the function using function notation. So, like it says here, we're just changing the name. We have seen, and we're used to this, y equals 2x minus 3. But function notation means that we swap out y and we put in f of x. So we would pronounce this, or we would say this, f of x equals 2x minus 3, and maybe you've seen that before. All that is saying, like you can see here, is instead of having y equals, we have f of x equals. We're saying that whatever this x is a function of f. And that might be kind of a confusing sentence, but we will look at it a little bit more in a second. You also, one note, you also will see g of x, you'll see h of x, maybe p of x. Those are some common ones, but they all mean that we are in function notation here. We'd say f of x equals 2x plus 5, or h of x equals 2x plus 5. So, I forgot to erase my slides here. To be honest with you, I had a practice one, and then it did not go as well as I wanted to, so this is try number 2. But, you know, that's how it goes sometimes. Anyway, if we have a question like this, what I'm going to do with these next few slides is go over the types of questions you will see on your homework. They're not anything that is a brand new skill. Really, we're going to build off the skills we already have and that we've learned, and we're just going to change the notation to this f of x or g of x so that we get used to seeing that, but we're not really learning a new skill today. So evaluate f of x equals negative 4x plus 7 when x equals 2. So the way that now with function notation that we can write this is like this. F of 2 equals 4 times 2 plus, negative 4. Negative 4 times 2 plus 7. So f of 2 equals negative 4 times 2 is negative 8. Negative 8 plus 1. Negative 8 plus 7 is negative 1. I was jumping ahead. So this would be the form that I would want your answer in right here. F of 2 equals negative 1. I would not just want to see negative 1. And really it's the same or very similar to what we're used to. What we are used to right now is seeing y equals negative 4x plus 7. Evaluate when x equals 2. Y equals negative 4 times 2 plus 7. Right? That's what we're used to, and we'd get the same answer eventually. But as you can see, with function notation, we take that y out of there and we introduce f of x, or in this case we're evaluating at f of 2. Another type of problem that you'll see on your homework. For h of x, this time we're dealing with h of x, but not, it means the same thing as f of x, so no big change there. For h of x equals 2/3 x minus 5, find the value of x for which h of x equals negative 7. So notice, this time we're finding the value of x, okay, for which h of x equals negative 7. So instead of plugging this into x, we're saying, hey, h of x, our end answer is going to be negative 7. So negative 7 equals 2/3x minus 5. And we're solving for x. This would be the same as, to draw another parallel, if they said y equals negative 7 and they said y equals 2/3 x minus 5, we would know right away, hey, we just take this negative 7, put it in for y, and we're solving from there. But with function notation, we don't use y equals, so we're saying h of x equals negative 7. Anyway, if we're solving, plus 5, plus 5, well, I don't want to cross that side out, I guess. That side I do. Negative 2 equals 2/3 x. I don't divide with fractions, so I multiply by the reciprocal. And x equals negative 3. And I can check my answer. I know you guys know this, but I can check my answer by taking that x equals negative 3, plugging it in for x, and if I get negative 7, that means that I did it correctly. But this is another type of problem you'll see on your homework. The last type of problem that you'll see on your homework, and this is kind of what we're going to dive into a lot more tomorrow, is looking at graphs and looking at how different values change our graph. But this is kind of a warm-up for it, I guess. But what you'll need to do is match the function with its graph. So I'm going to give you just a couple keys to look at right away. Before you start like plugging numbers in or do anything crazy, then I'm just going to give you a couple hints that we need to look at. First, if I am going to match these graphs, I want to look at the y-intercept of the graph that I'm dealing with. So if we start with number 19, the y-intercept of whatever graph this matches with, the y-intercept is negative 2. So that means A is a possibility, because that y-intercept is at negative 2. That means B is not a possibility, because that y-intercept is up there. And that means C is a possibility, because its intercept is at negative 2. So the first thing I want to look at is that y-intercept. Next thing I want to look at is the slope. And specifically, is the slope positive or is it negative? So this time we have a slope of -2. So our slope is negative. In A, this graph is going in the positive direction, right? If it's going up towards this first quadrant, then that means it is positive. So A is now off the table. Now, by default, we could see that it is letter C, but just to make sure, look, this graph is going up in the negative direction towards the second quadrant. So we didn't even, we did math, but we didn't really do math, and we found, just kind of by the process of elimination, that letter C goes with number 19. Now for 20, we're going to go with the same thing. We have a y-intercept of +2. +2, -2. Well, can't be this one, so that has to be B. And then by default, we see that number 21, I need a good color, number 21 has to be A, because A is our last one. But we can double check. It has a y-intercept of -2, and it's going in the positive direction. We have a positive slope here. So what I would do if I was matching graphs is I would first, again, look at the y-intercept, then look at the slope if it's positive or negative. If you look at those two things and you can't figure it out or you're unsure, you always can plug some numbers in just to see what matches up. So if we take this first one, if we wanted to just put 1 in, put x equals 1, we could start there. -2 times 1 is -2, minus 2 is -4. So this would say f of 1 equals -4, which tells us we said x is 1, and we just found that. The y value is -4. So there's one point that we know has to be in our graph. Well, we could see which one has a point of 1, -4. 1, -4 would be like right here. So it's not B. 1, -4, not A. 1, -4. Well, that has to be C. And if we still can't figure it out, then we can keep plugging some points in here for x, and we would be able to just keep plotting all the dots on our graph to help us find out. But if we don't have to plug points in, then that could save us some time. So, well, that is all that I wanted to look at for today. Make sure that we have a good understanding and good grasp of these things before we jump into part B tomorrow. Tomorrow, we're going to look at, well, you can see the slides here. We're going to look at a piecewise function, which maybe we're familiar with, a step function, and an absolute value function. So we're going to talk about tomorrow something called the parent function and what that is, and then we're going to see how adding, subtracting, multiplying, dividing numbers with that parent function changes our graph. So how we make changes to our graph. But don't worry about that today. Today, get this stuff done, and maybe you'll have a little bit extra time to relax. If you have any questions, as always, make sure you let me know. Otherwise, we'll